Okay, hi there, grade 10s. This is the video for Unit 5, Lesson 5. And today we're going to be talking about three things. One of them you may have talked about in grade 9, slope, but the other two I think are going to be new to you, called x-intercept and y-intercept. And you'll see here in brackets that I put that these are going to be the notes and the practice questions, these two sheets here. So you'll see that I'm going to do questions A, C, E, and H with you as the examples. And then the remaining 6 questions are going to be your optional practice questions. And so the solution is attached as a third page, so you can check over your work. So first I've just given you 3 definitions here. The first one is slope. Okay, so I said before that you may have seen this in grade 9. Slope is essentially the slant of a graph. It's steepness. So imagine like you're climbing this mountain, this line right here, if it were like a mountain or a hill, that's a very steep mountain. Okay, here it's not as steep. Here, this one we're actually going down. It's like we're running down the hill. So this would be an example of a negative slope. This would also be a negative slope because we're going down. And these two up here would be positive slopes. Okay, so the slope is essentially how steep your graph is. And we determine this by calculating rise over run. And I'll explain what that means in a second. Then the x-intercept is the point at which the graph crosses the x-axis. So you have 2 axes in a graph. You have your x-axis and your y-axis. So the x-intercept is where the line touches the x-axis at. So here's your x-axis, here's your graph. It touches the x-axis right there. So that would be your x-intercept. Your y-intercept is the point at which the graph crosses the y-axis. So this blue line here, for example, crosses the y-axis, the vertical axis, right there. For each graph below, determine its slope, x-intercept, and y-intercept. So we're going to find these 3 things for each graph. Like I said, I'll do A, C, E, and H. Okay, so I'm just going to number them 1, 2, 3. So slope is number 1. That's the first thing I'm doing. So to determine slope, we're going to do rise over run. I'm actually going to zoom in here so you can see closely what I'm doing when I talk about rise over run. Okay, so when you're calculating slope or you're trying to find the rise over run, what you do is you have to find 2 perfect points on a graph. And a lot of times when I give you a line, I will draw in for you perfect points. Perfect points is a point that's on the graph, so on the blue line, as well as it crosses perfectly the grid marks. You can see these like light gray grid marks all over the place. So this point right here, for example, is a perfect point because it's on the blue line and it crosses perfectly at an intersection of 2 of the gray grid marks. And so there are 5 perfect points here. To find the slope, you pick any 2 that you want. So there are 5 to choose from. You pick any 2. I've already colored that one in, so I'll choose that one. And I'm going to choose this one here as well. But you can try this with 2 other points and see if you get the same answer. And you should. What you do once you find the 2 points is you're going to calculate the rise, right? So we're going rise over run. So the rise is how much do I have to rise or go up in order to be in line with the second point. So it's like we hop. 1, 2, 3, 4, 5, 6. I had to rise or go up 6 units. Then we have to calculate the run, meaning how much do I have to go left or right to get from where I just ended to my second point. So from where I just ended right here, I only have to hop 1, 2. And I went 2 to the right. Okay, so my rise is up 6 and my run is to the right 2. Now, because you went up usually means positive. Actually, up always means positive when we're talking about this stuff. And because you went to the right also means positive. So our rise is positive 6 and our run is positive 2. And then all you do is simplify that. 6 divided by 2 is 3. And that's our slope, and we're done. Number 2 is our x-intercept. So where we cross the x-axis is right here. Now, here's 0. This is like a number line. So on the right, we go 1, 2, 3, 4, 5. On the left would be -1, -2, -3, etc. You can see right here, if you look closely, where I cross the x-axis right there, I'm not quite at -1 yet. Okay, halfway would be -0.5. I'm a little bit more than that. I would say I'm maybe -0.7. So I crossed the x-axis at -0.7, and I wrote in your notes up here, let's see if I can find it. When you're doing your x-intercept, at this point, y is always equal to 0. So when you're telling me what the x-intercept is, I want you to write it in terms of a point. And remember, a point is always xy. So I'm crossing x at -0.7. And at this point, right on the x-axis, y is 0. Because I'm not up or I'm not down. On the y-axis, I'm right in the middle. So I'm at 0. So that's your x-intercept. And then your y-intercept is where it crosses the y-axis at. So I take my line, I follow along until I touch the y-axis, this vertical axis right here, and I touch it right there. And that is at the value of 1, +2 for y. So here's 0. These numbers are negative, -1, -2, etc. These would be positive, +1, +2. Now be careful here. That's the y value. So we put that +2 in the y spot. And then again, I wrote that in your notes above there, your highlighted definitions, that for your y-intercept, x is always 0. Okay, so that's A. We're going to move on to C and do the exact same 3 things. Okay, so here's graph C. If you look closely, there are 2 dots, 2 perfect points colored in for you, and there's only 2 on the whole line, so I'm just going to use those exact 2 to calculate my slope or my rise over run. Now, it doesn't matter where you start. If you want, you can start at this point, and then to get to this one, your destination, you'd have to go down and over, okay? If that doesn't fit right with you, if you'd rather start at this one and this be your destination, you can start here and you'd have to go up, then over. It doesn't matter, you will get the same answer in the end. I'm going to start here, go down and over. So remember, it's rise over run. So in this case, I actually don't rise, I descend. I have to go down first. I have to go down 1, 2, 3 units before I would turn. So I went down 3. Then when I got here, I have to go to the right. 1, 2, 3, 4. I went to the right 4 units. Okay, so to get from point A to point B, I went down 3 to the right 4. Now be careful here. Because we went down, down means -3. Okay, but just like in example A, if we go to the right, going to the right still means a positive. So I have 1 negative value and 1 positive value. So be careful when you do your rise over your run. So my rise, or what I went up and down, I went down 3, so I'm going to go -3. And then my run, what I did left or right, I went to the right 4, which is +4. So that would be my rise over run. And I just simplify that. You can't actually reduce the fraction at all. All I can really do to clean it up is just to get rid of that positive. You don't need to write the positive, but it is still a -3. And that makes sense because what I said before is this is like a decline. It's like I'm running down a hill. So your slope should be negative. Okay. Your x-intercept is where your graph touches the x-axis at. So here's your x-axis, here's your graph. Where do they meet? They meet right here. And that is at a value of, here, if this is 0 for your x-axis, 1, 2, 3, 4, at +4. So my x value is +4, and like I said before, for your x-intercept, y is always 0 at that point. And then number 3, I want your y-intercept, so where your graph touches the y-axis. So here's your y-axis, here's your graph. They cross at that point right there. So if we start at our origin right here, our cross-section of the 2 axes, that's 0. So +1, +2. That is +3 for my y value. So that goes in the y spot. And then x is 0. Okay, I'm going to flip the page and do E and H. Okay, so this one's a little bit different because you can see it's just a completely perfectly straight vertical line. I want you to imagine slope like a treadmill, okay? I'm sure many of you have been on a treadmill in phys ed. And on the treadmill, when you get on it, it's perfectly flat, right? It actually looks like this. If this were the treadmill and you got onto it, your treadmill would be flat, meaning you're at incline of 0. You have no incline at all on the treadmill, okay? Imagine trying to get onto a treadmill like that. Well, that's absolutely impossible. You couldn't get onto it unless you're Spider-Man. You cannot walk on that. It's impossible. So whenever you see a vertical, completely vertical line like that, we actually can just say that the slope is undefined. Okay, undefined kind of means that's pretty impossible. Like if this were a mountain, we couldn't climb it. So we say it's undefined. We can't actually find a numerical value for it. Okay, so that one's pretty easy. 2, my x-intercept. So here's my x-axis. Here's my graph. Where do they cross? Right there. That is at a value of +1, +2, +3. So that is my x value, and then my y value is always 0. And then if we were in class right now, I'd say, okay, what's my y-intercept? And you guys would all look at me blankly for a second, and then someone would eventually say, there isn't one. And that's right, because this line never crosses the y-axis. They're completely parallel. They're like this. They're never going to meet. They just both go up and down. So you can just write a dash for me, or you can say there is none. Doesn't matter. Okay, but do not write 0. That is not correct. Okay, a y-intercept of that would be right here at the origin, meaning they would cross. Okay, I don't want you writing 0. Indicate to me that there is no answer. Okay, and H. Last one. Okay, so there are 3 points here. 1, 2, 3. You choose any 2 that you want. I'm going to choose the 2 further apart. Doesn't matter which 2 you choose. Okay, so for my slope, I'll do it right here. Now be careful here because you don't have a lot of grid, you don't have grid lines to jump on. You're going to have to kind of use the ticks to determine how much you've jumped. So again, we're doing rise over run. So if I start here, I have to rise up a whole bunch before I can start my run. So if I start here, and I'm kind of using this tick right there as my starting point, I have to rise 1 tick, 2 ticks, 3, 4, 5, 6, 7, 8. I have to rise 8 ticks. And remember, when we go up, that means +8. Now, I kind of screwed up here. Well, not screwed up, but I kind of, when I did my ticks, I kind of slanted and ended up over here. But if I did my ticks perfectly in like an upper straight line and ended there, I end over top of this tick right here. Okay, so I'm going perfectly up in a straight line. I'm over top of this tick. So when I start doing my run and going to the right, I start over top of this one, meaning I have to jump 1, 2 to get to the center. And if you look, this tick's right over top of, or this dot is right over top of this tick. So I have 2 more to go to get over to it. So I went 1, 2, 3, 4 to the right. To the right means positive. So my rise is +8. My run is +4. Well, 8 divided by 4 is just 2. Your x-intercept, so remember for your x-intercept, your y is always 0. For your y-intercept, your x is always 0. So for your x-intercept, your graph here, if you see where it crosses the x-intercept or the x-axis at, it's right there, which looks to me about halfway between 0 and -1. So that would be -0.5. And then where it crosses your y-axis at, this vertical axis, is exactly at +1. So there you go. You guys can give a try for the other 6 that are left. And then the last page of the solutions. So just take a look at the solutions there. And again, always email me if you're having trouble.